So this week we are going to talk about the statistical analysis plan, and this plan is also known as data analysis plan or reporting analysis plan. So the purpose of this statistical analysis plan is to have a analytic plan before conducting the analysis. Usually it is very common to have statistical analysis plan for randomized clinical trials, but for the transparency and for the clarity of how you are going to conduct your analysis, it is a very useful tool for even observational studies. So how do you really assess whether the statistical plan that you have developed is a good one or not? The first criteria is whether the statistical analysis plan that you have developed help answer the research question that you have set as your original objective. And the second criteria is, of course, some of the analysis that you have planned, are they correct in the context of the research questions. So I have downloaded all of these files in this folder, where the first example is the SAP example from the clinicaltrial.gov, and here you can see an example from a clinical trial where they describe the statistical analysis plan. So let's try to review what are the content of this statistical analysis plan. So first they talk about they list their names, the investigator names, signatures, and then some abbreviations, the table of content. Then there is an introduction, some description of the study design, how the clinical trial would be conducted, and then they have a detailed description of the flow chart. Then they talk about sample size calculation, which is essential for clinical trials in general. Then they specifically talk about what are the study aims and objectives, and then they talk about what are the outcomes of this analysis in accordance to their objective. There is a primary outcome, there is a secondary outcome. They also list a number of risk factors that they're using to adjust for their outcome. There is a third safety outcome, and then they are talking about the population and the subgroup analysis. So in the population, they are using two different type of estimator, the intention to treat or per protocol type of estimator, and then they have a predefined subgroup analysis or the subgroups that they will be using. So in terms of their analysis, they specifically talk about the software they will be using. They specifically talk about the primary outcome, secondary outcome, and they also talk about the missing data analysis. How will they address the missing data analysis when there are any missing values available? Even in terms of the outcomes, you can see they are specifically talking about how they will try to find the outcomes and what are the things they will include, and they will find the estimated difference in mean change from baseline to 12 month and the corresponding confidence intervals. So this is what a statistical analysis plan looks like for a clinical trial. However, for this particular course as a final project, you will be most likely using a survey data where the observations are coming from a observational study. So for that, let me show you one proposal example that I have used in a previous iteration of this course. I have downloaded that proposal, and that proposal is this one, where you can see at the beginning of the proposal we have a very detailed table of content, and then I have the document control version in which dates what was changed in this document, I talk about the broader research area, and then specify what are the PyCode elements, specify what is the hypothesis and aim. Then I also talk about whether the research question follows the finer criteria. Then I go to talk about population from the selected data source. Specifically, I talk about the study design. This is a cross-sectional design with the complex survey. And then I specify the study cohort. So basically the CCHS 1.1, 2.1 and 3.1 will be used in this particular analysis. And the study period is defined. So the study period is 2001 to 2005 because the CCHS 1.1 to 3.1 were collected during those period. The next part is the most important part, where I talk about the outcome variable, and in those 3 cycles of data, what are the specific outcome variable names. So in CCHS 1.1 it was CCCA, the CCHS 2.1 it was CCCC, and then CCHS 3.1 it was CCCE underscore 121 to determine and this variable was in particular talking about whether the patient has cardiovascular disease or not. In terms of exposure, I again have some variables that are indicative of whether that patient or subject has osteoarthritis disease or not. And there are some covariate details and covariates of interest. I talk about all of the different demographic variables, confounders, maybe some proxy variables. Say for example, I needed some information about cholesterol, but that cholesterol information was not available in the dataset, so I tried to look into the dataset to find out whether there is any proxies, and apparently the cholesterol and diabetes, also cholesterol and COPD are highly associated, so I have decided to include those variables as a replacement of this cholesterol variable. Also, diet variable is not available directly, but there are some information about whether the subject was had any fruit and vegetable consumption or not, and so I was using that variable as a proxy for diet. So in the same way, I have also tried to identify whether there was any mediator variable and things like that. Of course, whether a variable is mediator or not, that cannot be verified from a cross-sectional study. This has to come from a subject area knowledge. So if you are familiar with cardiovascular disease and osteoarthritis, this is something you probably would know. Alright, so in terms of the variables, so see, these are the particular variables that I am collecting from this dataset, and I have also listed the role of this variable, whether this is the exposure outcome covariate or whether this is a sampling variable. So in terms of CCHS data, one thing should be known to all of the users is that CCHS dataset do not give you any information about the strata or cluster. It only gives you the information about the sampling weight. So you can imagine that when you are using the sampling weights, you are probably going to get reliable estimates for the population when you are using the weights in your analysis, but in the absence of cluster and strata, your variance calculation will not be as accurate. So this is something to keep in mind, because in the enhanced dataset also they do not give you the direct information of strata or cluster, but they give you some masked or pseudo information of strata and cluster so that you can use them to get proper variance estimators. But in CCHS you generally do not have that privilege, or without having access to the micro data, you do not have the strata and cluster information. So we are talking about just the public information, so because we do not want to go through the painful process of ethics approval. So in that public data, at within CCHS you only have sampling weights, no strata or cluster information. Alright, then I also discuss how do I know that these are the variables that are covariates and mediators and confounders and things like that, and I cite a paper. This is a paper written by one of the previous SPPH alumni who was also working with some of the professors within SPPH. So this is a paper you might want to take a look at some point. Alright, so the next step is, since I know the variable, I just list all of the variable names from each of these different sources. So obviously arthritis is collected in, information is collected in all of these 3 data sources, but the names are slightly different, and you in the SAP I have listed all of these names that are collected from all of these different 3 data sources. I also list the classification that I'm expecting. Say for example, for cardiovascular disease I'm expecting event, no event, so 2 categories only. For age I have listed which age categories I want to see. For income I have listed what are the categories. For race I'm listing what are the categories and things like that. So you can see I have listed all of the categories specifically. I have also provided a DAG where I show the relationship between the exposure variable and the outcome variable. I also talk about what I will do with the missing values if there is any missing value. Then I talk about specific sample sizes and I present them in a flow diagram. So what is a flow diagram? This is a flow diagram where you can see from these 3 different data sources I'm creating a combined data sources, and from that combined data sources I'm excluding the subjects based on some exclusion criteria. Say for example, in my study other type of arthritis patients were not eligible because I did not want them to be in my study, so I have excluded them. And then I list what is the exact sample size, and then I have excluded the subjects where the outcome had any missing value, and that led me to some additional new sample size. And then I chose not to keep any teens. I only wanted to keep 20 and only wanted to keep the subjects who were between 20 to 64, and that reduced some sample size as well. And then I deleted some variables, variable values that were associated with non-response or who did not want to respond, and that gave me the analytic sample size. And then I divided that to with respect to the exposures. So these are the exposure number, these are the non-exposure number, and then I have listed among the exposure people how many of them had the outcome, and among the non-exposure people how many had the outcome. So this is a very detailed flow chart where you can see all of the exclusion criteria, what are the sample sizes at each step, and this is something that you need to report in your statistical analysis plan, because in there you also need to have a very good understanding about your data set and which data is available and which data is not available. Even if some data is available, if there are 90% of the data are missing, that is not really usable. So at the stage of building your analytic strategy, where when you already have access to your data, this is important. All right, then I talk about the analysis strategy. So here you can see a template of a table where you can see this is the control subject and this is the case subject, and I exactly list the variables and the variable categories that I'm expecting, and I also list which category I'm showing, because the other category is going to be the base category, right? Alright, then I talk about some model building strategy, variable selection strategy, table 1, and some exploratory figures and sensitivity analysis. So as you can see, and also at the end I also talk about some potential pitfalls and how I'm going to address that. So this is a very detailed and statistical analysis plan that might not be possible for you to build by the end of this month, but what we have done in the next year is that we have moved away from that detailed analysis plan to some template which will be easier for you to fill out. It mostly includes many of the information that we have included in the previous year, but this is the format or template that you are going to use in this year to report your statistical analysis plan. So in here also you are going to report your PICOT, your hypothesis, your whether you think this is a causal analysis or association analysis, your final criteria, what are the exclusion criteria. You need to think really hard about your exclusion criteria. What are the variables that are potential confounders or risk factor? What are the demographic variable? What are the survey features such as the weights, strata, and stratification information, and the variables chosen in the dataset will give you the list of names that are chosen from the dataset. And also you need to list the variable sizes and the flow chart and what is going to be your primary analysis. Is it the logistic regression or not? And then you have the code book. Say for example, if you are using enhance as your primary data source, then you need to list the variable name, component name, what is the target, what is the meaning or concept, what is the role in the analysis, variable type, code, variable description, updated description. Then you need to talk about or provide a table 1 where you are stratifying by the outcome, and optionally you can paste your regression output, which is the basic crude regression, the association between your outcome and exposure without adjusting any confounder. Right, so this is the template. So just for your benefit, I think it will be helpful for you to see a template where I have filled out an example. So in here you can see I have filled out the PICOT element, hypothesis, whether this is a causal question, final criteria, exclusion criteria, what are the variables and what are the name of the variable in the data set that I have chosen, what are the exact steps that I'm going to take to create the analytic data set, and what are the exact sample sizes in those data sets, what is the primary analysis. In terms of code book, this is the worksheet where you will be spending most of your time. See, this is the age variable, right? So in that age variable, what is the name of that variable in the dataset? So in here I was working with an enhanced dataset. I got that variable from a demographic component, and what was the target or universe for that particular variable. What is the meaning of this particular variable? What is the role in the analysis? Is it a covariate, exposure, outcome, or a mediator? Is it a categorical variable or continuous variable? What are the codes 1 and 2, and what does those code mean? And updated value and updated code. So for male and female, I'm not going to change anything, but say for example I am dealing with a variable called race, and there were many categories, but I do not really want all of those categories. Part of the reason I may want reduced number of categories is because there are not enough data set in each of these cells when I cross classify them, right? It is usually a good idea to cross classify any of the variables that you are considering with the outcome variable and exposure variable. So for example, in the next slide or next worksheet, you can see there is a cross classification of all of the variables based on the outcome. But I think it is also a very good idea to cross classify all of the covariates with the exposure as well. And if you see some of the categories have very small amount of observations. Say for example in here you have only 12 observation, and if in some categories if you have even less number of observations, so those are the categories you need to think a bit more. Is it possible to maybe merge these poor and fair categories? Is that going to be problematic for interpretation when you are trying to interpret? And you have to take into consideration of that when you are having something like 17. Is it a good idea to kind of merge it with the other categories, and is that hampering your interpretation? So these are the some of the things that you need to consider when you are considering. And you can also paste the crude regression, the association between the exposure and outcome variable, in the next worksheet. Also in the scientific writing page, you can see I give a very brief description of the enhanced data that I have used in this particular template that I just show. So you can take a look at that enhanced example where I give some idea about what are the outcome, exposure, comparison group, and how I have accessed those variables from the enhanced website. And that's how I have determined all of the names of the variables and collected those names in my statistical analysis plan. So if you take a look at the lab for this week, where I talk about how to directly access the enhanced data from the CDC website and download them using R in your computer, you will have a much better understanding of how the process really works, the identifying the variables and downloading the specific variables and creating an analytic data. So that will probably be more helpful for you to start working with your statistical analysis plan.